Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture for July 9th of 2025 is titled A Beautiful Trifid. So, what do we see here? Well, here we see what is known as the Trifid Nebula, also known as M20, and this is an example of a nebula, and in fact one nebula that shows all three major types of nebulae that we look at. So when we look at it, we see the different colorations. We can see the reddish color towards the center, we can see the blue color around the edges, and we can see dark lanes going through the middle of them. Now, what these are three different types of nebulae. So the dark areas, as we look at first, dark nebulae are dark, dusty areas. So when we look at those, we're not looking at regions without material, but regions with excess material that is actually blocking out the light from behind us. So if we could remove those, this would be just a little more steady red and pinkish color through the center. But there are certain areas where there is a sufficient amount of dust that you cannot see through it. Now, the pink itself is actually caused by hydrogen gas. And what's happening at the center here is we have young stars that have formed and are still forming. Those very young stars, the first ones to form, are very hot, and that means that they emit a lot of ultraviolet light. The ultraviolet light will ionize the hydrogen gas. Essentially, it strips off the electron that hydrogen has, and then that recombines together. So it will recombine with the hydrogen atom, and as it does that, it gives off energy. And for hydrogen, it gives off a distinct red color that we see here. So when we see red gas generally in the sky, that is a sign of hydrogen. Now the blue, on the other hand, is completely different. It is not caused by the energizing of a specific gas. It is actually dust again. So dust, when it's dense enough, gives us the dark dust lanes that we saw earlier. The blue color we see is what is called a reflection nebula. Now, a reflection nebula will occur when the light from those same hot stars that gave us the pink Emission nebula then is scattered off of dust grains. So here it's still the same dust, it's just not as dense. And that means this light is then scattered, and the light is scattered preferentially is going to be the shorter wavelengths. So based on the dust that we see, the shorter wavelengths are better able to be scattered, meaning that the blue light appears to come from that dust, and the red light seems to go straight through. Now this also kind of applies to the dark nebulae that we see. In visible light, we see nothing because that light cannot penetrate through the dust. However, if we were to look at this in the infrared, we would be able to see into those regions and actually see where stars are currently in the process of forming. So, star formation in an area like this is not done yet. It is still ongoing. And as the new stars form, they eat away at the material, pushing it backward, outward into space, and eventually come back in a couple 100 million years, and we will just have a cluster of stars with just some wisps of gas left around them, as everything else will have been expelled outward or have been formed into new stars. So that was our picture of the day for July 9th of 2025. It was titled A Beautiful Trifid. We'll be back again tomorrow for the next picture. So until then, have a great day, everyone, and I will see you in class.